So considering 3 resistors in series and the ratings as per the manufacturer's P1V, P2V, P3V, the voltages and the power and the voltage respectively. Supposing I am connecting it incidentally to supplied voltage which is also V. Then this is the rated voltage, okay. So then this is R1, R2 and R3, and R is equal to R1 plus R2 plus R3, and you know that when it comes to the rated voltage, the formula is P is equal to V square by R, and therefore you know P is always inversely proportional to R. So substituting that formula here, R1 is V square by P1 plus V square by P2 plus V square by P3, which is equal to V square by P. So 1 by P is equal to 1 by P1 plus 1 by P2 plus 1 by P3 is the equivalent power. So now you know the equivalent resistance, you know the supplied voltage is V, you can find the current that is flowing through, which will be a constant, so I is equal to V by R1 plus R2 plus R3. Once you find this current, you can find the individual power consumed by using the formula IR1 square, IR2 square, IR3 square, which are the power consumed or the brightness. You know the brightness, these are the brightness formula. And if you see that if current is constant, since current is a constant, its resistance is maximum, which will happen when the rated power is minimum. Power rating is minimum. A bulb which has got power rating minimum will have a maximum resistance which will grow with maximum brightness. Maximum brightness. You can't increase the brightness anymore because resistance has already become maximum. The current is anyway a constant. But what happens if the current suddenly increases beyond a safety point? Then this will be the bulb to fuse first. So you should understand that the one with the minimum power rating or the maximum resistance is the one which will glow with the maximum brightness. And you can't increase the brightness any further by increasing the current, because if you increase the current or the current goes beyond the safety limit, you know, the bulb is going to fuse. So let's go to next one, where you have 3 resistors, all of which are connected in parallel, and you have a supplied voltage V here. You know this is rated again P1V, P2V and P3V are the individual individual ratings, and the formula for P is equal to V square by R is the rating, and so 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 because the resistances are all in parallel. So 1 by R itself is V square by P1 plus P2 by V square plus P3 by V square is P by the supplied voltage V square. So V square gets cancelled, P is equal to P1 plus P2 plus P3. So once you know the power, there's no need to find current here. You don't need to, because the current is going to get split. The voltage is a constant. Since you know the voltage directly, you can directly find the brightness of these individual bulbs by using the formula V square by R1, V square by R2, V square by R3 will give you the brightness. Directly it will give you the brightness. You don't need to find the current here. So once you get this formula, you know, for if the resistance, okay, for the brightness to be maximum, say brightness to be maximum beyond which you cannot increase the brightness, the resistance here has to be minimum. For the resistance to be minimum, the rated power has to be maximum. You know, so then highest voltage will have the minimum resistance, which will give rise to maximum maximum brightness, beyond which if I increase, so supposing the bulb with maximum voltage, the current in the circuit is increased the safety limit, beyond the safety limit. For example, this current is going to be increased. So then in that case, this will be the first bulb to fuse again. Because beyond which you cannot increase the brightness. So any increase in the current in the circuit exceeds the safety limit, the bulb with maximum wattage, maximum power wattage, rated power wattage is what is going to fuse in the parallel connections too. So either way, if you see, The one which has got the, okay, in this it is in the series connection, the one which has got a minimum power voltage and the parallel connection which has got a maximum power voltage is what is getting fused. Okay, let's do some sums for you to understand all this better. I'll repeat the sums I did in the morning so that you're clear. The first sum for the day, current is 4 amps, flows through a resistance of 12 ohms. For rate of heat energy, you know, heat energy in itself is work done, which can be VIT, or instead of V can I square RT IR, or I is V by R, so V square by R into T. These are the various formulas for heat, which is because P is W by T, W is heat and it's power into time. So power into time, power into time, power in each case into time. That will give me my heat energy in general. And the rate of heat energy is a term which is nothing but power. Is nothing but power. So they are asking only power. And they have given I and R, therefore I'll use the formula I square R. Because I have a direct formula, so I can use that and I get 4 whole square into 12 and get answer as 192 watts. So that's the first sum. Second sum. How many, heating element is rated 210 volts and 630 watts. It's a rating. These are the rating. This heating element, which has been rated like that, is been connected to our 210, incidentally at the same voltage, 210 voltage. What is the resistance of the element? Okay. So you know the voltage, you can find the current through, because the question is about resistance, you can calculate the current. P is equal to VI. So I is equal to P by V, which is 630 by 210, which is 3 amps. I know 3 amps is the current that's going to flow through the circuit, and applied voltage, V applied by the current that's flowing through, which is 210 by 3, will give me 70 ohms, which will be the resistance. That's how you calculate the resistance. Okay. You can't use the formula. What happens if you use P is equal to V square by R? P is equal to V square by R. And I try to find R directly, V square by P. V square is 210 into 210 and power is 630. This is 21 3s are. And this is 70. So you still get the same answer. So therefore, you know, you can either use this, you can find I and you can do that, or you can directly use the rating itself and find the resistance of the circuit. P is equal to V square R. V square is 210 by power is 630. So 21 3s are and 70, you still get the same. There is no change. Okay. So then you can still calculate it either way, it doesn't matter. The third question is a 10 volt storage battery with a negligible resistance. Okay, I have connected in series with a 50 ohm resistor, which is an alloy of manganese. How much heat energy is produced in 1 hour? So when it's heat energy is VIT. And you know this R has been given, so you can use the formula V square by R into T. That's better because you have been given 10 into 10 by 50 into time, which is 3600 seconds, and you get the answer as 7200 joules. Let's go to the fourth question of the day. A 50 volt battery draws a current of 12 amps if a motor yields a mechanical power of 150 watts. 150 watts. Yields means power consumed. Power consumed. Power supplied we can find using this. P is equal to VI, which is 50 into 12. 12 by 60. So 600 watts is the power supplied. And this is the power consumed. This is the power input. This is the power output. And efficiency is replaced by eta, which is power efficiency percentage, is power output by power input into 100. So it is the power output is 150 by 600 into 100. That will give you the efficiency, which is 25%. So let's go to next sum, which is fifth sum of the day. An electric motor working with 50 volt DC supply draws a current of 12 amps. the efficiency is given to be 30%. They are asking you to find the resistance of the windings of the motor. Resistance of the windings of the motor. See, the resistance can be found only with a balanced 70%, which is responsible for loss of heat, because resistance is what leads to loss of heat. Resistance is what is lowering the efficiency. So with the efficiency loss is what is useful for me to find the resistance. So what is power here? Power is VI, which is 50 into 12, which is 600. And a 70% of this 600, 420 watts, is what is going to be responsible. What is the power loss due to this resistance? The power loss due to this resistance. And I'm going to use the formula, power is 420 is equal to, I want to find the resistance. So I use the formula I square R because current has been given. So it's 12 whole square into R. So 420 by 144, which will give you 22.9 ohms. Because I know the current has been given. So I'm using that to find it, okay? So let's go to next sum, which is the sixth sum of the day. Let me choose something else. An electric power station. Not this. Okay, electric power station, it's NCERT sum, 100 megawatt, transmits the power to distant load through a long and thin cable. And which of the two modes transmission would result in lesser power wastage? The power voltage of 20,000 volts or 200 volts. Which of this is going to be useful for power transmission, effective power transmission? An electric power station is 100 megawatt, which is 100 into 10 to the power 6 watt. That is the power supplied through a thin long wire is there, and one has got 20,000 volts. Two modes of transmission would result in lesser. Okay, one mode of transmission which involves 20,000 volts, another mode which involves 200 volts. So you know P is equal to VI. From the first one we can find what, in this case, what will be the current is P by V, which is 100 into 10 to the power 6 by 20 into 10 to the power 3. So this will be 10 to the power 3, this will be 5. So 5000 amps will be the current that is flowing through in the first case, in this combination. Next, let's do the sum in the other combination, which is using this combination. Yeah, let's do the sum. P is equal to VI and I is equal to P by V. So in that case, it will be 100 into 10 to the power 6 by 200. In this case, you will get 5 into 10 to the power 5 amps. So you get two different values of current. So once you get the values of current, these are all normal connections, so you can just use I square R, and P1 is equal to I1 square R, and in this case power is I2 square R. You can find the power consumed using I1 square R and I2 square R. And since you found the current, it's 5000 the whole square into the resistance, you don't know the resistance, keep it as R, and in this case it will be, because resistance is going to be the same for this, it's the same wire, okay, so it's 20,000 the whole square into R. This is also in watts and this is also in watts. So can you see that since the resistance is going to be the same, it's not going to change, P2 is greater than P1. P2 is greater than P1. Hence there will be lesser power wastage when the power is transmitted with 20,000. The first one. there will be lesser power voltage. This is say P1, this is P2. You know P2 is greater than P1. Lesser power wastage. What we have calculated here is the wastage. The power in other words, due to the resistance, the power wastage that we have calculated here. We're comparing both the wastages due to this long wire, the resistance of the long wire, and when the voltage is high, you can find the current, and the current, depending on the current, you calculate I square R, the power that is wasted, and then you know that the 20,000 volts is more efficient, lesser power voltage. So therefore you have to transmit at 20,000 volts and not at a high voltage. Transmission is better. So that is your understanding. Okay, so let's go to next sum. Heater coil, which is, what is this? Someone's question. A heater coil is rated at power is equal to 100 watts. The voltage is equal to 200 volts. It is cut into identical parts. Both parts are connected together in parallel. Oh, so first we're coming across some parallel connection. Okay, so you're coming across a parallel connection. Heating coil, which is long coil, which is rated at 100 watts and 200 volt. It is now cut into two parts. Both the parts are connected together in parallel to the same source, which is 200 volt. Calculate the energy liberated per second in a new combination. Okay. What about the original? If you're connecting this is 100 volts. Now it's been cut into two. So let's find the resistance of this using the formula P is equal to P is equal to V square by R. You know P, you know R, V, you can find the resistance, which is 100 is equal to 200 the whole square by R. So R is equal to 200 into 200 by 100, which is 400 is the resistance. And so this is going to be connected in parallel. This will become 200 and this will become 200. And so then the equivalent resistance, therefore R1 into R2 by R1 plus R2. So it is 100 ohms is the equivalent resistance. Now that equivalent resistance, you can find the current through the circuit. The new voltage that is supplied is 200 by 100, which will give me the current through the circuit, which is 2 amps. So now that I know 2 amps is the current through the circuit, and do I need the current through the circuit? What for? And this they've asked, calculate the energy liberated per second in a new combination. So we can calculate the energy liberated per second. Power is rated which work is done. Per second means they are asking for just work done with 1 second, which is power, VI. So which is VI. Okay, we can use the formula. This is parallel. We can use the formula V square by R for consumed power. Basically for consumed power you can use V square, brightness. Where we use V square by R, consumption of brightness, V square by R. So we can use this V square by R because we don't have to find I in this, it's not necessary step. So it's voltage is 200 the whole square by R itself is 100. We can stop the sum with that. There is no need to find I. There is no need to find I. When voltages are constant, your consumption is based on V square by R, that's all. You are not using I there. So that completes that sum. So next sum is the 8th sum for the day. 100 watt bulb at 230 volt, this is the rating. Okay, these are the ratings. This is connected to a 150, much lower voltage. And if the supply voltage, 1 second, hold on. So this is the rating, 100 watts and 230, 100 watts and 230 volts. Okay, and this has been connected to a voltage which is much lower than the rated voltage. Okay, so what will happen? Let's do the study. Okay, what's the question now? A bulb is marked 100 watts. What is the heat and light energy produced by the bulb in 20 minutes? So time is given 20 minutes, so it's 20 into 60, which is 1200 seconds. So what is the heat and light? Okay. First in this question you see that this has been given, and you know P is equal to V square by R, from which you can straight away find the resistance rated. This is rated power and rated voltage, from which you can find the resistance, which is V square by P, which is 230 the whole square by 100, which is 230 into 230 by 100. You get 529 ohms. You get the equivalent resistance of the circuit. You can find the current through the circuit based on this. And I is equal to applied voltage 115 by 529. I is equal to V by R, so that you can get the current through the circuit, which will be 5 by 23 amps. Is the question about current through the circuit? The question is about calculate the current flowing through the circuit. Yes, that's one part of the sum. Calculate the heat and the light energy produced. Brightness. The brightness for this, you'll use the formula.